this is the overall phenomena of bonding in carbon monoxide and metal carbonyls, carbon monoxide in isolated form and metal carbonyls when metal is attached. So, whenever we are talking about soft metal, now I hope that you know the what soft ligand is. So, soft ligands are those ligands which are at least this is one characteristic that which are capable of back bonding. So carbon monoxide has this characteristic or possess these characteristics which can accept. Let go a little bit back and refer to previous concepts of acids and bases. And if you are aware of soft and hard acids and bases, so soft acids are those acids are soft easily. Other valence shell of a metal or any other element, it increases, and whenever this number of electrons increase in the valence shell, it makes the species a soft species. So whenever we are referring to the periodic table, so on left hand side we have hard metals, and on right hand sides are when we move toward right, so we actually increase the soft behavior, soft characteristics, soft properties. So, whenever this carbon monoxide is treated with any metal which is right or establish a very stable bond between soft metal uh, with a soft metal. While on the other hand, when we are treating metal with carbon monoxide, which is situated on left hand side of the periodic table, so on left hand side the metals are hard and soft because now we know the ligand is soft and hard soft interaction. Also, we know that this is unstable. So the bond between those metals which are at left hand side of the series, they will make unstable bonding with carbon monoxide, while the metals on right hand side will make very stable bonding with the carbon monoxide, metal and carbon monoxide. So let summarize it that where soft metals are and what type of oxygen. Alkoxides are also coordination, also act as ligand in coordination chemistry, and alkoxides again oxygen is the ligating center. So whenever the ligating center possesses more electron pairs, so the situation is now inverse or different because in case of carbon monoxide, it donates electrons to through sigma bond, and it accepts big electron through pi bond. And on the basis of this phenomena, carbon monoxide was called as pi acceptor ligand. On the other hand, whenever we are talking about water as a ligand, so in this case, water will donate a pair of electron to metal center, which are available. So from these two pairs, any one pair can be donated toward metal center, or it can be donated to a metal center in order to make a coordinate covalent bond, which is the prerequisite of coordination chemistry. Now, if the metal possesses electron pairs in d orbital, and the metal desires or metal is capable to donate that pair of electron to this ligand. Now it depends upon the situation or orbitals available with this ligand. If the appropriate orbitals are available, the ligand will be capable to accept electrons. If appropriate orbitals are not available, then the ligand will never accept those electrons. Now, for electron acceptance or bond formation, there are certain phenomena. One phenomena is orientation of orbitals in the space. So, if the orientation of orbital is appropriate, bond will form. If orientation of orbital is not appropriate, then bond will not form. Next, appropriate position. If one orbital is acting another orbital, then one orbital is shifting, other orbital is acting, there is no empty orbital. So empty orbital and the orbital which is completely filled can overlap, and in that case coordinate covalent bond will form. In other words, we can say that bonding is possible. Next phenomena, which is according to my opinion is third one. The energy of these orbitals is very important. So whenever the energy of these orbital is comparable, then they can overlap. If energy is different from each other, then the orbitals will be unable to overlap with each other. So these three phenomena, that orientation in the space, energy of orbitals which should be comparable, and appropriate occupancy. If these three phenomena or these three characteristics are present between two combining species, then stable bond is possible, otherwise no bond is possible. So in this case, let the oxygen possess two pairs of electrons. Now oxygen can donate a pair of electron easily to a metal center. If the metal desires to donate back a pair of electron to this type of ligand, now it depends whether this type of ligand possesses orbitals to accept that pair of electron or not. So if you look at oxygen, which is a begetting center, and to this oxygen immediately there is no multiple bonding. So it means by far orbitals are second pair of electrons to a metal if the metal possesses appropriate orbital, and that orbital is empty, and energy of this orbital which is available for pi bonding or additional bonding, and that orbital on metal which will accept this pair of electrons. So if the energy is comparable, then bonding will form, and such type of ligands are now called, yeah, in that situation we will call these ligands as sigma donor as well as pi donor. So sigma donor and pi donor ligands are those ligands which are sigma as well as pi donor. They are generally termed as hard ligands. So water is hard as compared to carbon monoxide, or you can categorize other type of ligands with this type of ligands. So those where immediately no multiple bonding, and this is one situation where no multiple bonding is present. So most probably those ligands will act as hard ligands. Now, besides the multiple bonding, we have also to look for other arbitral